Welcome to Number Sense Trajectory for K-2 teachers, hosted by the Missouri Council of Teachers of Mathematics. My name is Amanda Schweiskuth, and I am extremely excited to have all of you here today. First, let's look at our agenda. We are going to discuss what the number sense trajectory is and what those early number sense concepts look like that are discussed in the trajectory. We will also look at the 4 components of number sense, and throughout the slides, there will be different activities and resources linked, which you will have access to. Number sense is a critical skill that our students need if we ever expect or want to get them to a fluent stage with their operations. Number sense is also something that we cannot just teach in a series of 3 lessons throughout the school year. Number sense has to be developed by the student. They have to experience numbers and see how they can manipulate them and change them in ways that make sense to them. This is not going to happen overnight. It's not going to happen in a 1-week unit. We need to give our students experiences throughout the school year to play with these ideas, to talk through these ideas, and really develop their own understanding. There are several foundational number concepts that will help with this, and those are what we're going to outline in the number sense trajectory. A research study by Greg Duncan, an education professor at the University of California, Irvine, found that the early math skills are one of the best predictors of later success in both math and literacy. I think this just hits home because although many of the skills that we teach at K-2 may seem very simplistic, they're actually very complex ideas that our kids are struggling with and trying to make some meaning of. So let's look at the number sense trajectory. And first, I want to let you watch this great progression video made by Graham Fletcher. And Graham Fletcher is also the one that created the number sense trajectory document. So let's look at what Graham Fletcher has to say about this progression.
Before we ever get to addition and subtraction, and long before we tackle fractions and decimals, there's so much understanding that needs to take place. So here I'll try to explain the progression of early number and counting. Well, before students come to us in kindergarten, they begin to see what numbers look like. I mean, literally. Check out these dice. Students know that there's 4, 2, 3, and 5, but they don't know that quantity. They're just simply calling out number names and matching them to what the things look like. They know that we have 3, 3, 5, and 4 on the yellow card. What they're doing is matching a number name to a visual pattern. This is a really big piece, but a lot of kids are able to do this before they come to us in kindergarten. This ability to recognize quantity without counting one to one is called subitizing. Some say sub, some say su. I just say it's magic. But here, if we were to show the number 4, a student might say 4. Yes, they know the number name, but if you ask them to prove it, they might count them 1, 3, 9, 7. This is a perceptual subitizer. They cannot explain why it's 4. I think most of us are familiar with the conceptual subitizer that would say 4 because there's 2 and 2 more. In this early trajectory, we're talking about a perceptual subitizer. So as students are working on this idea of subitizing, they're simultaneously building their understanding of more and less. Let's take these 2 hands, for example. If we were to put some candy in each hand, and then we were to ask a student, which one has more? I think most students are going to say the one on the right has more. And they're able to recognize this because they can visually see and compare the difference. They can't tell you exactly how many more, but that visual representation of more, well, that ties back to what they're doing with subitizing. The students don't need to count to compare the quantities. If we were to take some candies from the right hand, put them in the left hand to where they're equal or almost the same, now we have a need to count. So when students come to us in kindergarten, we now know that they have this idea of subitizing and more or less that they've been working on. So from there, we introduce rote counting. Rote counting, well, it's kind of like this. As students are learning the alphabet, they might say LMNOP and have no idea that there's actually letters embedded in there. Rote counting, same thing. Students are just working on that count sequence, the reciting of names. So, an example of that would be as if we asked a student to count from 1 to 6. They might say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We said stop at 6. But you know what? They can't. They have no idea where 6 is in that count sequence. Well, in kindergarten, students should be working on that count sequence from 0 to 100, forwards and backwards. I think most students in kindergarten have had exposure to a hundreds chart or a 99 chart. But what about this one on the right? When the value increases, the numbers on the chart rise up. Now when we count up from 0, we don't go down, we actually go up. That might make more sense to kids. Something to think about. So as students are working on this idea of rote counting, we begin to introduce this idea of one-to-one correspondence. And to be honest, one-to-one correspondence, it's much more than simply tagging numbers to objects. Here's an example. If we ask a student to count 8 and place them in the bowl from a set, and they're able to do that, they're a producer of counting. They're able to do that one-to-one tagging to 8. Now, if you ask them how many were in the bowl, they don't know. They'd have to go back and recount them all over. A student that we'd ask how many didn't make it inside the bowl, well, they're a counter. They can count a finite set of a quantity. So for instance, there was 4 that couldn't make it. So we want to make sure that students are both counters and producers. And one way we can do that is by building this understanding of tagging, but not always with numbers. So here we have 6 bears, and we want to match each bear to a green present. This idea that's happening in one-to-one correspondence, it's really, really big, and we need to make sure that we devote enough time for our students to develop this understanding. So as students are working on rote counting and one-to-one correspondence, cardinality gradually makes its way into the conversation. What cardinality is when students are counting out a set of objects. The last number in that count sequence describes the quantity in the set. Students might count this pattern here of these pennies, but they might double count some. So now they use a counting strategy where they line them up and count from 1 to 8, and they know that they said 8 last, so that there's 8 in the count sequence. This was an example of a counter with the pennies, and on the bottom here with the rec and rec, we have a producer of 8, and they're able to tell you that it's 8 because of the last number. We then move on to hierarchical inclusion. Yeah, it's a really big word, but all that it means is that students understand that numbers are nested inside other numbers. So if we take that penny, for example, students would know that if you had 8 pennies, you must have 7 pennies. That numbers are nested inside the numbers. So if we ask students to put 7 inside this circle, do they need to count out 7 pennies, or do they just remove 1 and drag the set into the circle? The same idea with the rec and rec. Do students count out 7, or do they just know to remove 1 because 7 is nested within the 8? And at the final part of this progression of early numbering counting comes number conservation. The big idea here is that students understand that there's a decomposition of number. We might ask, are they the same? Students would say, yeah, we have the same number. But if we stretch out the blue row and ask which one has more, students might say the blue. This is at the heart of number conservation. It's about decomposition, that numbers can be broken apart, and that numbers, the whole, is made up from parts. So at the beginning, we talked about a perceptual subbatizer. Well, here we have 3 sets of 4. Well, when students get to this piece in the number sense trajectory, they understand that 4 is made up from parts. So now when we show students these dots and we show them these yellow cards, they're able to see that 4 just isn't a name, it describes the parts of a whole. Now we're getting to that conceptual subbatizing. There's a whole lot happening here. One thing to remember, the turtle won the race. Thanks for watching.
Let's continue the conversation on Twitter.
Take a moment to pause this video And ask yourself, what really surprised me from what I heard in the video? Or what questions am I still thinking about and want to know a little more? And just maybe jot down a few ideas before continuing with the video. So this is the top of our number sense trajectory that Graham Fletcher created. And you can see at the bottom, he's also listed his resources that he used when creating this. So how does this knowledge about these phases or this progression, how does that understanding apply to where we are currently? And just think about that with your students at whatever point in the school year you are. And how will this knowledge and understanding impact where we go next and in the future? So if I have one student who is still in the counting phase and a different student who's in the cardinality phase, how does that impact my future skills that I'm getting ready to teach? Or how does that hinder that student when they get to those future concepts that we need to teach? The next part of the number sense trajectory shows our key four number relationships. And these are absolutely critical for students to be able to build the flexibility that we want them to have with numbers. The big picture of all of this is how the students flow through this from left to right. And it also aligns vertically. These first two slides that I showed you for the number sense, they line up with each other top to bottom. And notice if our students have their basic perceptual subitizing and the basic comparison skills, they have the skills necessary to build up their spatial relationship and pattern set recognition. If a student is lacking with their cardinality understanding, that is going to make their one and two more or less a little more difficult for them to understand. So having all three of these skills is crucial for students to truly be able to comprehend the one and two more or less strategy. Our hierarchical inclusion and our number conservation skills allow students to move into understanding anchors and part whole. So why are these four number relationships so critical or so important for our students to really grasp and understand? We've got our spatial relationships, one and two more or less, benchmarks of 5 and 10, and the part whole. These are the four components that really build the flexibility with numbers, and that helps them really understand how the numbers work and how they relate to each other. This flexibility is absolutely key for students becoming fluent. Look at how this aligns with the addition and subtraction strategies that we teach in K-2. Looking at our near doubles, make 10, and our double facts, there's a reason that these are gray. Our hierarchical inclusion and our number conservation go down into our benchmarks of 5 and 10 relationship, and it went down into our part whole relationship. Those two key relationships are critical for kids to be able to do make a 10 strategy or to do their doubles plus one more, doubles plus two more strategy. And over here, the one and two more or less addition subtraction strategy obviously connects to the skill or the relationship of numbers with one or two more and less. And even our facts with zero connect directly back all the way up to our one-to-one correspondence and our rote counting and our cardinality. So let's talk about the first key relationship of spatial relationships. This is our concrete and pictorial representations of the numbers themselves. We can do subitizing, do work with 5 frames and 10 frames. There's a great structural tool called MathRacks or ReckonRecs that build that conceptual understanding for students. We can use dice, showing numbers on our fingers, using number paths and even tally marks. And not just picking one or two of these. Our kids need the flexibility between the different representations and understanding that 5 tally marks really do mean the same thing as the first 5 that I put inside of a 10 frame. One way that you can build up this number relationships for students is using quick images, as some call it, or subitizing. And it's simply showing an image quickly, just for a short time, and letting kids say what they saw, how they saw it, and how many. There's a lot of great videos online for this, and I've also added in a few of my favorite resources for subitizing. There's Splat from Steve Wyborney. I have some Van de Waal dot cards, and it's a file that you can open and use. Graham Fletcher has made some great subitizing multiplication cards and geometry. And then Christina Tondevald has a great series on how to use subitizing in your classrooms, not only for K-2, but she also made a 3-5. So each of these are linked, and again, you'll have access to those slides so that you can get to those links. Back to our key relationships. The next one is 1 more and less or 2 more and less. The big thing here is it encourages the flexibility with numbers, and it really aids kids in mental computation. They can quickly think, oh, 1 more is 6. Oh, 1 less is 7. Whatever number they're at, they don't have to stop and count. They don't have to go back and look at the picture. They just know quickly what 1 more or 1 less is. And this also supports and builds a stronger understanding of that hierarchical inclusion for the students. If we think for a moment of how many addition facts that we're trying to get these students to become fluent with and eventually hit an automatic phase that they just know them, there's 121 addition facts that we're really expecting these kids to know. And then when we're done with that, we're going to have them do another 100 or more multiplication facts and division facts. I don't know how there's room for much more. A strategy or a relationship as simple as 1 more, 2 more, 1 less, 2 less can actually help students tackle this long list of addition facts. This is a great image I got from Christina Tondevald's website. She's also known as the recovering traditionalist. And this image just makes so much sense. So when we're looking at the facts that we need students to have, we've got a couple strategies shown in the darker colors. So our dark purple on here is simply our 0 facts. 4 plus 0, 5 plus 0, 6 plus 0. Our dark blue over here is our 10 plus some more facts. So if our students know that 10 plus 4 more is 14, those facts are shown in the dark blue. Our dark green on this diagonal are our 10 facts. Right here, we've got 5 plus 5 is 10. If I come up a little ways, I'm looking at 8 plus 2 is 10. And then our orange, the dark orange on the opposite diagonal, is our double facts. So 16 I know is 8 and 8. But we also have these light colored. We've got light purple, light blue, light orange, and light green. That is showing that if our students know their zeros, they know their 10 plus some more, they know their 10 facts, and they know their double facts. Everything else can be solved by doing plus 1 or 2 more, or minus 1 or 2 more. Just for an example, if my student knows that 10 and 5 make 15, well, then when I'm trying to figure out 9 plus 5, well, that's just 1 less than 10 plus 5. So 1 less than 15 is 14. Or I could go even further to the 8 fact. 8 plus 5 is 13. I don't know 8 plus 5, but I do know that 10 plus 5 is 15, and 8 is 2 less. So my answer is 2 less than 15. Oh, that's 13. This can be a very great tool for students to use so that they don't have to really memorize all of these, which we're not trying to memorize in the first place. But if they can be really strong with 0 facts, 10 facts, their doubles, and their 10 facts, everything else can be tackled with the plus 1 or 2 more. On to benchmarks of 5 and 10, another one of our key relationships. As always, it gives them flexibility, but this time it gives them flexibility to decompose and compose numbers quickly. When students can think of 7 and just know, oh, I see a 5 and a 2, or they can think of 9 and go, it's only missing one more from 10, then they can use that within those mental math strategies very quickly. This is also something that's critical for students to learn the Make 10 strategy. Our part whole relationship builds on the last three and the different components. It requires that understanding that eight is not just eight. Eight also is comprised of seven, it has a six, there's a five. All those other numbers are part of it and can be broken apart. This is incredibly powerful for students when they begin adding beyond 20. Just a few things to keep in mind as you find activities or games for kids to explore and build up these different relationships. Remind students when they're excited about using these strategies from their toolbox that they can come to a fact that they don't just know yet. If there's something you don't know off the top of your head and you can't tell me in that split second, it's okay. We've got this toolbox to come back to. Also, think about how you can keep the kids discussing. Maybe they're at a math station without you, and the math station is built to develop these skills. How can you encourage the discussion and the sharing of their strategies? How can you keep speed out of the activity? When they're trying to develop these skills, we don't want them focused on how fast they can add two more in their head. We don't want them focused on who did it faster, them or their partner. It builds a fear of failure, and we don't want them to shut down while they're trying to develop through that progression. And then when can I come back as a class and have those group discussions? They learn a lot from their peers and they gain a new understanding that maybe they had not seen yet when they're sharing with one another what they've seen. Just a few last websites as you begin to explore and find ways to develop these with your students. NCTM has a great website called NCTM Illuminations, and this is from the National Council of Teachers of Mathematics. They have a 5 frame and 10 frame tool that the students can use. They have a couple games that I've listed that really focus on these different four key relationships. Greg Tang also has great free games for students to play and virtually explore these different concepts. All right, our final slide is just the tiny URL that if you use will take you to the slideshow itself. And this will allow you to click on the links and explore the different resources that I have in here. As always, please share this information with fellow colleagues. Feel free to make a copy of the slides and use them to help other teachers in your building that may also benefit from this information. Thanks so much for coming and continuing to learn with me. Have a great day.